Hello and welcome back on my channel Sheet Metal Workshop. Well, in this video I have a small project. It's called Project Pipe Rack, and I have here the pipe rack besides me, and it's actually a training pipe rack from the Learning Insulation School in Hamm in Germany. So thank you very much to the Learning Insulation School in Hamm for loaning me this pipe and to have an opportunity to make a video about it. So, and that is what it is about. And well, okay, well, let's have a start. So I'm gonna measure this pipe rack. I'm gonna fabricate it. I'm gonna insulate it, and at the end we do the cladding. Now the whole pipe rack thing will be cut out by a laser cutter machine, the Ultra Cut from Schwartmans, and I'm going also to give an example of digital measurements. Well, that is it, and also by hand measuring. Okay, well, first what we do is, that is what I'm doing when I come somewhere on the site. And first what I'm doing is I'm gonna analyze what kind of job it is. So we have here pipe work, and I already see we have here two boxes. I have here some different dimensions of pipes, and all depends on how much experience you have with measurements. I, for example, can immediately recognize the pipe. So I recognize this is a 2-inch pipe, there's a 1.5-inch pipe, and here we have a bigger one, it's a 3-inch pipe. But if you're not having experience, there are tools you can carry with you, like this for example. And if I want to know for a 3-inch pipe how much the outside diameter is, I just catch the diameter and I read it, and I see here, okay, it's almost 90 millimeter diameter outside. Okay, and the same thing you can do. It's a good tool, you have to carry it with you. It all depends on the experience. That's one thing I recommend. The other thing is, it's also not bad if there are a lot of angle pipes. So this is a good tool for measurement to do with angles. So I have here this angle pipe, for example, and I can here hold this here exactly here on the angle. See, and now I can read here, and it says we have here 40, so 45 degrees we have there. Now there's also a helping tool. It's of course, the more tools you use, the more you have to carry with you. So that's one thing. It's not bad, you can put everything in a little bag and carry it with you. I use mostly almost always my ruler. So this is a ruler, and I can also measure the angle with my ruler. Here I'm going to measure the same angle with my ruler, and I fold it, and it says here 766. Now I have here a list, and on that list is my ruler list. On the one side I have my sizes from the ruler, and on the other side it's the degrees. So here we have 766, that means 45 degrees. So what I'm doing when I take measurements, I always write down my ruler measurements, and then later on I look in the list and look how much degrees it is, that angle. Okay, well, let's get started. So we are analyzing now this pipe rack. I can see we have 1, 2, 3, 4 pipes are coming up, and then we have here one pipe in between, and we have here also down here also one pipe in between. Now I'm not going to measure everything in detail. I mean, I will do it, but not on video, so it will be too much time. And I think it's the best way. I'm going to measure here this part in detail, how I will do it. Maybe so once I'm gonna measure it normal by hand and drag it on paper as a sketch, as a normal isometric drawn by hand with my drawing template. And the other version is the digital version, but there we will come later back on that measurement. Okay, well, I will say let's have a start. We start now measuring, and I hope you will enjoy the video. Of course, there are many measurement guys, everybody got his own experience, so it could be there are other versions of measurements. Maybe someone's got something better or easier. I don't know. I'm going to do it the way I would do it, but everybody is welcome to put his meaning in the comments. Every comment and is welcome. Okay, well, let's get started. Okay, now I'm standing here now in front of the pipe rack, and this will be actually now my view side. So from this side is my where I'm starting to measure it. It all depends on the situation on the side. Maybe it's also possible I'm standing at the other side of the pipe rack and I will measure it. Maybe I will see it then differently. But in this situation, I'm going to measure it from this side. So this is my front view, and it's always good when you put pipes with segments that you don't look into the swages, and if possible also when here we have here this band that we put the screws from this side if I'm looking at it. So at the end is when the cladding is on it, you cannot see the seams or the screws. Okay, now next thing, I'm gonna give those pipes then position numbers. So I've decided to make each pipe differently. I think it's easier. So when this is here, pipe number 1, for example, this would be number 2 position. Here we go here up until here. I will make this position number 3. Then we have here this one. Maybe this would be position number 4. Then we got that band also until here, position number, or until here, position number 5. And here this band with the angle here, position number 6. And then at the end, the pens, the Ypsilon T pipe, I will make position number 7. But now for this example, I'm going to measure position number 1. And before I start, I know I'm going to write the pipe dimensions. So it's a 2-inch pipe. That means it's got an outside diameter of 60 millimeters. So I'm going to write here 60. And I know it's going to give 50 millimeter insulation. So that means 50 millimeter. I have 50 millimeter on this side, and on the other side that makes together 160 millimeter diameter. But from my experience, I think it's always better to make it a little bit bigger. So I give 10 millimeters more. So I'm gonna make it diameter 170. Okay, well, that's the first information I write down. Now, next thing, what I'm going to do, I'm gonna draw this pipe. So how it goes, so it goes up, and I can already see it's a 90-degree bend. And then we have here also a bend that's also got an angle, and then it goes straight, and then here also a lying bend with an angle, and then we have a 90-degree bend, and we have here also an angled pipe with a T-pipe also angled with the same diameter. Okay, good, that is the stuff I analyzed. So I'm gonna start drawing. You can draw it directly with the drawing template I made a video about, so you can draw it directly or freehand. So mostly I do first freehand and later on I drag it over on an isometric or I put it digital. Okay, well, let's start. So my pipe is now going here, goes up, and then it comes to the front, and then it goes to the side, and then again here, then it goes up, and then there, T-pipe, and here it's another pipe, and this one goes a little bit like this. Here we also have got an angle. Here we do an end plate. Okay, now we see here the T-pipe is coming in and the seam is also out of the center, and this one here also got an angle. So what we're going to do first, we're going to find out we need here this length, and we need to know the radius. Now, here in this situation, you can see here there's a seam, a welding seam. So if I hold my ruler on this welding seam and I go from this end to the center of the pipe, so here's my center of the pipe. Wait a minute, yeah. So I will have here 130 millimeter. So my radius is 130. So I can here already give here R is 130. Okay, and I'm gonna give it a 3-segment bend. So 3 parts. Okay, so that's it. So what I need now is I need this length, and I'm gonna start here, give this length from here also down. There's a welding seam from here until the center of the pipe. So I'm gonna hold my ruler here and then look here. Okay, here's the center. So you have to imagine here a straight line. Sometimes you have to guess a little bit, but in this case, okay, 410. So that length is here 410. So I always measure from center till center. Okay, now I need the second length is from this center pipe until the center pipe of that angle here of the bend. So therefore I'm going to put here my ruler and then look here. So I've put here my ruler. I have 769. 769. Angle 769. Okay. So now here, for example, this angle, if you look here, this line from this line here, see, it's one line. So if I turn now here this angle like this, and I go with this parallel line just here, okay, here, like this, it's still the one line, see? And if I look here, so it's symmetrically. So that means this angle is also switched by this angle. It's the same angle. Okay, now while we're at the angle, you can also check here, and it looks pretty much it's also the same angle. It's the same angle. Okay, it means what I forgot. So if you put this here, this angle here, that means this point here, that's my center. So from this center point, I go to the center of this pipe here. Wait a minute. So I will say 26, yeah, 260 millimeter. So that's 260. And I want to have here seam, and here this seam is also 76.9. Okay, then I have here end piece, here piece. So I want to give here, we're gonna measure it now. Therefore I need first here this one, this angle,
Can also measure it same way. See, like this. And here I have also 716. So this angle is also known, 716. And now same thing here. So I hold it again here. And so this is here now my center line. So if I hold my pen here exactly in the center, it means here, that's my center point. And from that center point until this one, oh yeah, here we have 715 millimeter. 715. Okay, 715. Now here's a T-pipe coming in, so it wouldn't be bad that I make here this band until here, and then a piece of pipe here with the seam to the side, so it's easier maybe to fit. And then here the next piece starts with a band. So here I have already did that before, so we have here a complete size from 715. And now we have from center here until center here 230. So that's for the cutout, for example. 230, that's just, I notice, okay. Okay, so we give here, for example, 100. So here I have seam 100. So 615 is left. 615 is left, so 100 plus, for example, we go here 500 until here. Okay, so I give here 400. And then automatically 500, so this is 215 is left. Okay, well, here we have normal the seam on the side, and here is also coming a pipe. Here normal seam. Now I need here this distance. So we go here now, the angle, here's the center of my angle I marked before, and then we go here until the center of the pipe, and that will be 200. So that's 200, and we need also this radius. We have here a welding seam. So the other one was 130, so let's check it if it is the same. 130. We have here also the seam of the welding, so 130 radius. So we give here also a seam, and this size is 130. Okay, now here we have 60 millimeter, and it's got an angle 741. This also, wait a minute, you can also measure it like this. We have here also got here these angles on the ruler, so can also show the other method. Now we have here 120 degrees. Here 120 degrees. Okay, 120, 180 degrees. minus 120, so this angle is 60 degrees. 60 degrees. And well, normally if this pipe goes parallel up and this one also, so this is still here, you see that this angle still there. Now we check it if it is the same one. Well, it looks like it is. So it's also the same angle, also 60 degrees. Now, this pipe's got the same diameter, so diameter 170. And now we measure here from center pipe until center here where the seam is. We have 440. Now, I could make a seam here in the middle. Can also make it out one part, but I would like here to have a seam. And this one we're gonna make out of two parts, the T-piece, so 440, so I can split. I give 220, 220. Well, that's it. That's now my isometric as a sketch. And if I now bring this over, so this was an example, if I bring this sketch now over and I want to draw it for the isometric, it would look like this. So this is the end result. So I have here also marked here the positions. I turn those rulers in degrees. And now here position 2 is coming here in with a T-piece as an example. And here, this is position 4. See position 4, I with a dot line also with a T-piece. So that's additional information here also. Position number 5. So that is now, I have explained a little bit about the drawing. And the next thing is how it looks like when I bring this sketch over now in digital form. Now, okay, now I have here now got my tablet with the ISO Connect software on it. That's the software from Schwartmans. And this is now the way I'm going to show how to do it in digital form. So just, I'm gonna drag over these sizes on the computer. I have also a little bit experience on sites, so when I measure and I have my tablet with me, well, it sometimes can be uncomfortable because you need both hands sometimes to measure, and then you put your tablet somewhere on the side. I mean, there's a possibility that it can be damaged, so you have to be always careful. So I like mostly always make a sketch and then drag it over directly or in the computer, or I make an isometric of it. This is the software. And here I can pick, for example, a different language. So there are many languages available, and I will pick, for example, here English. Okay, and we can here choose development or cut. So we go to in the development. And now I come automatically in the pipeline section to make. So I will give here my project pipe rack, for example, and here I can give the diameter, I can give the insulation thickness, the bow radius, and the number of segments. So I'm going to give the diameter I already know, so we said 170 millimeter diameter. I won't fill the insulation. I give here 130. I mean, it's also possible to give the naked diameter and plus insulation, but because I give 1 centimeter more, I do it like this way. And here we have also 3 segments. So these are now my basics size where I start with. My cord got a width of 1 meter. So now we go here in the isometric. So I have here those arrows, and I can also turn it on or off, and then I can use those numbers. For example, here where the pipe goes up, we go here, press number 8, it goes up, and then it comes to the front, and then it goes to the side, and it goes one straight, next one, here one to the side, goes up, and then in that direction. So this would be now my first design. So next, what I'm going to do, come back here on the first segment. So I give here a length, we have measured 410. So we have here now a length of 410, and we said here the in-between size was 260, and that band had an angle of, for my ruler, when I drag it over in degrees, it has an angle of 42 degrees, but I want to make it out of 2 segments, so only 1 segment in it. So now maybe it's better to see, and I want to have that length, we said 100. Okay, now this piece in between, we said we make it 400 long. We can here also change the seam. Now this band starting segment we gave 215, and it's got an angle of 73 degrees. Okay, and the size in between was 200, and yeah, okay, and then we got here this band, we give it also a length of 130. I'm gonna here make it also a little bit bigger, want to see it better here. Okay, now here this band we're gonna make also made out of 2 segments, so we have here a little bit more space. See? Okay, now the next size we took 60 millimeter, but we had an angle of 60 degrees with no segment in it, and this one, so it's always the one in blue when I give the sizes. So here that we said 220, and here also 220, and now right here we want there a T-pipe. This one is turning, yeah. Okay, and now here the angle 120. So that is it. Make it a little bit smaller. Okay. The only thing is here the seam here, and I wanted to have it out of 2 parts, so there's only 1 seam. So I have here an option to make it out of 2 parts, and here the seam is now there. So that is my starter part, and here also we wanted to change the seam position 45 degrees, but we wanted to have it on 42 degrees. So that is the seam where later on the T-piece comes out. Well, okay, well that's it. What I wanted to show now, I memorize it, it's stored, and now I want to have, for example, go in the menu. There's a lot of different stuff here to choose, so I go now in the boxes, serial caps. Okay, now we are here now in the program for the boxes, and we have here some boxes, A, B, C, D. These are types of boxes, so I'm gonna press once on A, and then we have down under those numbers 1, 2, 3, 4, 5, 6, 7, and these numbers are what kind of types. So 4, 5 and 6 are end plates, and number 7 if you have boxes with a flattening, and number 1 is 2-part, number 2 is 3 parts, and number 3 is made out of 4 parts. So we're going to make a 1. So position 1, it's got a diameter of 270 millimeter, and it's long 250. So this would be now the 3D version. And if I go back and I want to have it as a standing, so here there's an arrow, I press this one and I go now in 3D, so now you can see it will get a crimping edge. Now what I also can do, I can also make the cutout. So, and I need 2 boxes. Okay, well that's it. So these are the cut sizes. So, and that's the procedure. So now it goes directly into the ultra cut.
Okay, well, that was it, what I wanted to explain in this video a little bit. So for measuring, on making a sketch on an isometric and dragging it over in the computer, so now the laser, ultra cut laser from Softmans can cut it, and that is the next step what I'm going to do. I have to say it's a challenge for me to do this, so I'm looking forward. I hope I do everything okay and right. Okay, thank you for watching. See you in the next time, next video. Bye.